So go ahead and get that title. Today is January 11th, and in order to actually do the work that we're doing today, we have a formula that we're going to be using. And this is going to be a very important formula. This is something that you will use far beyond just an algebra classroom. We'll be continuing to use this probably throughout the remainder of the trimester, even the remainder of the year, potentially. You will use this in geometry. You'll use this formula in Algebra 2. This is a formula that a lot of you have probably seen already. So it's something that isn't going to go away. It'll keep coming back over and over and over. And so it starts off by saying that the slope formula, it's just a formula that we're going to use to figure out the slope, same thing we did yesterday. This formula is used to find the slope between 2 points on a graph. And so instead of being shown the points visually on a graph, today we're going to be told what the points are as numbers, as coordinates. And so we end up with these 2 points on a graph. You've got this first one, which we're calling x1, y1, and the second one, which we're calling x2, y2. The numbers 1 and 2 here, they only refer to the first x coordinate and the second x coordinate, and the first y coordinate and the second y coordinate. There's nothing really like special or complicated about it. It's just differentiating between this x coordinate versus that x coordinate. So for example, in this first problem, this number 1 here, that would be x1. This number 4 over here, this would be x2, because this is the first x coordinate and that is the second x coordinate. And so this 1 right here would be the first y coordinate, so that's y1. And this 3 over here would be the second y coordinate, so that would end up being y2. And so that's how the slope formula ends up working. And I'm going to write what the formula is here, and then we're going to use it, and that's all we're doing today. It's a lot of subtraction and then simplifying fractions. So subtracting and simplifying fractions. The most complicated things that you will run into today are just remembering the process for subtracting negatives. That's going to be the biggest thing in terms of calculations, what we're working on today. So if you end up needing a calculator, like I said, please grab one at any point. But let's go ahead and get this written down. So our formula is y equals, not y equals, why did I do that? That doesn't make any sense. We're not using y for our slope. Oh, I'm still on vacation. Okay, let's try this again. M equals, because that's our variable for slope. We use m for slope. So m equals. And then we're going to have a fraction. And it's going to be kind of a large fraction to begin with, because we're going to end up subtracting. And I'm going to use some colors to make these a little bit more easy to see, and we'll be able to kind of match these up as we go through. So the x coordinates, I'm going to go with red. So I'm just going to use red for the x coordinates, and I'm going to use blue for the y coordinates. And so on the numerator, we saw yesterday that the numerator, the top number, was the rise, the change in the verticals, the vertical values, which are the y values. So on the numerator, we're going to have the difference in the y values. So we're going to have y2 minus y1. So y2 minus y1. So it's actually the second y value minus the first y value. And on the denominator, it's the same order, but it's with the x value. So we're going to have x2 minus x1. And there's a reason why I'm using black for the subtraction instead of blue and red on the numerator and denominator. Does anybody think they might know why? Why would I be using, there's a reason why everything here that's black is black. And there's a reason why everything that's blue is blue and red is red. And even more importantly, I think the most important part of this is making sure that the subtraction here is black and not blue or red. Does anybody think they might know why? Why might those not have the colors of X and Y, even though they're on the numerator and denominator? Okay, let me ask you a question then. Is this subtraction, is that part of this number? No. Okay. So this minus is not part of that number. And it's also not part of this number either. And so when we're plugging in for these values, this minus will always be there. And this minus will always be there. It is not part of either of those numbers. Sometimes these numbers will have their own negatives, which means we will be subtracting negatives on occasion. And so I think using these colors hopefully will help us to be able to see a little bit easier what's happening when we run into things like that. So let's go ahead and just start working on some examples. The more you practice these, the more you'll come to understand how these work. Some of you have probably done this before, so this might be kind of like a, yeah, I get it, we've done this. But if not, it's a good strategy, you know, to just kind of use different colors if you have them, because it gives a visual representation of what goes with what. So our first example, we've got the 0.11 and the 0.43. And so I'm just going to label all 4 points, x1, y1, x2, y2, and I'm going to label them using the colors that we used up top. So there's x1 right here, and here's x2 right here. So you got x1 and x2. And then we have y1, and we have y2. So those are the 4 numbers that we're going to use with this formula. And so this is a substitution process. We're going to write the exact same thing that we did here up in our formula, but we're just going to replace it with the numbers that we're saying each of those is equal to. So I'm going to write m equals, and I'm going to have a fraction bar. And then I'm just going to follow this formula up here. What number is above y2? Over here. What number is equal to y2? 3. So I'm going to start by writing 3. And then minus, what number is equal to y1 in this first problem? 1. So the numerator is going to be 3 minus 1, y2 minus y1. And the denominator is the same idea. x2, what number is x2 equal to? X2 is equal to what? 4, yeah. So the denominator 4, and then minus, what is x1 equal? 1, good. So 4 minus 1 on the denominator. So all we're doing is substituting in, and then we're going to do the subtraction on the numerator, the subtraction on the denominator. And after that, we're going to reduce the fraction if we need to, and we'll be good to go after that. So the subtraction on this one, I think pretty straightforward. 3 minus 1, we know that's equal to 2. And then 4 minus 1 is equal to 3. And that's our answer. The slope is 2/3. So we have a rise of 2 and a run of 3. And we were able to figure that out without needing a graph. So slope of 2/3. All right, let's try another one. Problem number 2. Our first x coordinate is that first number, which is -2, so that's x1. Our second x coordinate is the 10, so that's x2. Our first y coordinate is the 4, so that's y1. And our second y coordinate is that -2, so there's y2. So those are the values that we're going to use, that we're going to plug into our formula. So we'll throw them in, do a little bit of subtraction, figure out our answer. We're going to say m equals, set up our fraction bar. And somebody tell me, what is our numerator? What's going to be on the top? What math problem are we going to write on the top? Somebody let me know. What are we going to write on the numerator of this fraction? What's that? The top. -2 minus 4. Yes. And then 10 minus -2 for the denominator. Yep. So we got -2 minus 4 on the numerator. Again, the subtraction, I'm not using the colors for y1, y2, x1, or x2 because the minus is part of the formula itself, and the x1, x2, y1, y2, those are the numbers that we're bringing in. So on the denominator, we've got 10, and this is where it's going to look a little bit different, minus x1 is equal to -2. So I get a red minus or a red negative and a 2 down here on the denominator. So the minus is part of the formula, and the negative is part of the number for x1. So that's why we end up subtracting a negative. So we've got the regular minus. There will always be the minus here, but sometimes you will also have a negative with the number that you bring in. So subtracting a negative, and this is where, you know, some people have had in the past some challenges with subtracting negatives. Even with this numerator here, -2 minus 4. What is -2 minus 4? What does that equal? -6. Good. Because if we start at -2 and we take away 4 more, it keeps going down on the number line, which puts us at -6. All right. Over 10 minus -2 is +12. Yeah. 10 minus -2. Subtracting a negative is actually the same as adding a positive. So we can actually just make that 10 plus 2, which is 12. Now I'm going to remind you of a little thing up here where it says it is important to remember to simplify your answer. Now we didn't need to simplify the first one because it was already simplified 2/3. This one here, however, -6/12, this one will simplify or it will reduce. So what does this end up equaling when it gets simplified? Close. -1/2, yeah. So there we go. Just as a quick little reminder about calculators here. These calculators are actually really nice because you can type in this entire problem and it'll go straight to that answer if it's typed in correctly. So we can set up our fraction, and this is something that we did before the break, and our fraction button is this little n/d button here, numerator over denominator for a fraction. And it actually writes it out, or it's going to write it out as a fraction with our numerator and our denominator. So on the numerator, we had -2 minus 4, and the denominator was 10 minus -2. And we can type it in exactly as we wrote it on the paper. And then when we hit enter, it's actually going to give us our answer, -1/2, exactly as we had it over here. So you can keep working these out by hand if you would like to, or you're more than welcome to give the calculator a try. The only thing about the calculator is that in order to get the right answer, it has to be typed in exactly correct. Otherwise, it might not present you with the answer that you need. So let's do 3 or 4 more as a class, and then I'll have you work on the rest of them on your own. And I've got a note about the second page of notes as well, real quick, once we get through a few more. So number 3. Let's go ahead and work through this one. So we got x1, first number, -4 is x1. x2 is over here, -8. And we got y1, so the first y value is this 5, and the second y value is the -5, so there's y2. And then we're going to have our formula. All right, the top of our fraction, what math problem are we going to write? Using the formula, what is the top of our fraction going to say? -5 minus 5. I like it. So y2 has its own negative. So that's -5. And then minus the other 5 there for y1. Now on the denominator, the bottom, what subtraction problem are we going to write on the denominator, on the bottom of the fraction? -8 minus -4. Excellent. So -8. So each of our values of x this time has a negative with it. But we also need to make sure that we have the minus in there as well. So -8 minus -4. So there's the math problem that we are writing for number 3. -5 minus 5 over -8 minus -4. Just to clarify, -5 minus 5 is not 0. What is -5 minus 5? -10, yeah. So if you start at -5 and you take away 5 more, you end up all the way down at -10. And on the denominator, -8 minus -4, well, that would be the same thing as -8 plus 4, which is still a negative number. It's just not as negative as it was. What do we get? What's -8 plus 4 equal? -4. Good. And so we get this fraction that says -10 over -4. Well, fractions are really, mathematically, there's no difference between a fraction and division, right? Dividing and a fraction are the same thing. So I want you to think about this for a second. A negative number divided by a negative number is always a what? It's always a positive number. So if you have a negative on your numerator and your denominator, that means that this fraction is actually a positive fraction. So when we simplify this, we're not going to have any negatives in our answer. It's going to be a positive number. And then this simplifies. Each of these numbers is divisible by 2. And so 10 divided by 2 is 5. And 4 divided by 2 is 2. So the slope of this line is 5 over 2, or 5/2, and it's positive. And again, we can use the calculator, and it should end up with the exact same number that we have here. So here we go. -5 minus 5 on the numerator over -8 minus -4 on the denominator. And there it is, positive 5 over 2. All right, let's do a couple more here. Number 4. Let's label x1, x2, y1, and y2. So here's x1 is 10, x2 is -2. And we've got y1, which is 0. And y2 over here, which is 4. All right. We got everything labeled. We've got our fractions set up. What math problem are we writing on the top of this fraction? 4 minus 0. Perfect. My hope is that this ends up feeling repetitive. If it ends up feeling repetitive, that's a good thing. That means you have, you kind of learned the process. In my mind, in math, if something feels repetitive, that's a really good sign, because you're like, oh, I've seen this, I'll go ahead and do it. It's when every problem feels completely different, that's when we're like, all right, we need to keep practicing. But if you get to the point where you're like, I've done this, this is feeling a little repetitive, I'm good, that is a good thing. So -4 minus 0 on the numerator. On the denominator, we've got -2 minus 10. -2 minus 10 on the denominator. So 4 minus 0, that's just 4, over, what does -2 minus 10 equal? Negative 12. Good. Start at negative 2, take away 10 more, we get to negative 12. All right. And does this simplify? Yeah. What does it simplify to? 1 over negative 3. Exactly. And just as a matter of like form, it doesn't actually matter where that negative goes. So I just want to point out that 4 over negative 12 and the negative off to the side here and 1/3, negative 1/3, that's the same thing. The negative could be up with the numerator, it could be off to the side of the fraction, or it could be down with the denominator. Most of the time, you will see the negative either with the numerator like we did on number 2, or off to the side like we just did with number 4. Most of the time, you will not see an answer with the negative on the denominator. Even though it's not wrong, it's just not something that's very common to see. So if your fraction has one negative, that negative can go on the numerator, it can go off to the side, or on the denominator. It doesn't really matter where it ends up, but traditionally, it's either up with the numerator or off to the side. So there's number 4, negative 1/3 for our slope. Rise over run. All right, we're gonna do 2 more together, and then we'll go ahead and I'll have you work through some more. And then, like I said, I've got a note about that second page that I want to talk about before you do the work on your own. So number 5, let's take a look at that. So number 5, our first number, x1. Our second x value, 3, x2. First 9 here, y1. Second 9 over there, y2. All right. Has anybody started working on this one already? You find anything weird about it? Or maybe not weird, but like anything really different about this one than the other ones that you saw? All right, go ahead and grab one of those, one of each. All right, what are we going to write on our numerator? What's our numerator problem that we're writing? 9 minus 9, cool. All right, so we got 9 minus 9 on our numerator. How about the denominator? What are we writing down here? 3 minus 5, good. All right, 9 minus 9, that's just 0. And then 3 minus 5, that's negative 2, but that doesn't actually matter because 0 divided by anything is what? 0. So the slope of this line for number 5 is 0. What does that tell us about what kind of line this is, based on what we saw yesterday? Yeah, it's a horizontal line. If the slope is 0, it means it's not going up or down, it's a horizontal line. So I'm just going to make a quick note here. I'm just going to draw an arrow right there. I'm just going to say horizontal. Just as a reminder, anytime you encounter a slope of 0, that means that the line is a horizontal line, no matter what. So it's always good just to remind yourself of that. So I usually just write, if it's a slope of 0, I usually write the word horizontal just to be like, okay, every time I see that, I'm going to write that word just so I know that that's the kind of line I'm looking at when I have that slope. Number 6, let's move on to that one. And then this will be the last one that we do as a class. So number 6, we've got x1 here, negative 7. And then the second x coordinate is over here, negative 7. So x2. And then we've got y1 for this 8. And then the 5 over here is the second y coordinate. So that's y2. Okay, on the numerator of our fraction, what are we going to write? What's the math problem for the top of the fraction? I know a lot of people know what it is and just don't want to say it, but what do we think? What is it? Yeah, 5 minus 8. Good. So y2, 5, minus y1, which is 8. All right, how about the denominator? Yeah, -7 minus -7. All right, so minus, and then the other -7. Okay. So something happens on this one, and the numerator 5 minus 8, that's -3. What about the denominator? What do you get when you subtract -7 from -7? -7 plus 7, okay, which is 0, okay. Now, is this slope equal to 0? I see some people saying no. I hear some people questioning yes. It would be undefined. Yeah. And here's why. So if we look at number 5 real quick, if I use my calculator for this, if I say 0 over -2, it gives me 0. Okay. Over here, if I have -3 over 0, I have, it gives me an error. My calculator says divide by 0 error, can't do it. So 0 on the numerator gives you an answer of 0. 0 on the denominator, your calculator freaks out and is like, why are you asking me to do that? I'm not allowed to. This is not a thing. Mathematically, you can't divide by 0. And so since it's not possible, this is the one that we didn't even end up with a slope for. This was our vertical line. This was undefined. So this is undefined, which means it's a vertical line. So these first 6 problems, we've pretty much seen the variety that you're going to run into on your assignment. So before I have you work on 7 through 12, I want you to go to the second page real quick. And I went ahead and made a decision. We're not going to do anything after problem number 12. So we're just going to not worry about that, or 13 through 20. So the one thing that I wanted you to be able to do today is calculate slope using the slope formula. I don't need you to worry about anything after that. The skill that you would be using for 13 through 20, it's not a bad thing to learn, but it's not vital. And it is something that you will catch up on at a later time, probably in geometry. So we don't need to worry about this right now. I just want to make sure that you're able to get slope using the slope formula. So that's what we got going on today. So what I would like for you to do is take the next, let's see, we've got 6 problems, let's say 15 minutes to work through those. So that'll put us right at 8:50. So at 8:50, I'm going to do the same thing I did yesterday. I'm going to randomly call on people, see what you have for an answer. If you need some help as you're working through this, please raise your hand and ask. I'm happy to help you out. And if you need a calculator, please go grab a calculator. Oftentimes that really speeds up the process so long as you are using the calculator correctly. If you're using a calculator and you need some reminders on how to use it, feel free to ask on that as well. So at 8:50, we will reconvene and I will randomly call on folks and see how we did on this, and then we'll wrap it up and you'll get your assignment. Go ahead and give this a shot. First person I'd like to hear from for problem number 7 is Sophia. Do you have an answer for number 7? -2 over 1. Nice. -2 over 1 or just -2. Excellent work. So here it is for number 7. We've got, I did not put colors with these last 6 that we did. I just did those for the first ones. So we got y2, 3 minus y1, 9. 3 minus 9 is -6 on the denominator. x2, 2 minus x1, which is -1. 2 minus -1 is the same as 2 plus 1, which is 3. -6 over 3 equals -2 over 1, or just -2, either way. Nice work. So that's it for number 7. If you don't have that, please make sure you get that written down. Next, I would like to hear from Creed. Do you have anything for number 8? -3 over 2. Good. Nice. So we got -3 over 2 for number 8. Y2, -2 minus 13. -2 minus 13 is -15. 6 minus -4 for the denominator is the same as 6 plus 4, which is 10. And -15 over 10 reduces to -3 over 2 because they are each divisible by 5. Excellent. For number 9, let's hear from Karen. What do you have for number 9? -1. Good. So it could be -1 over 1 or just -1. Scoot that down so you can actually see it. For the numerator, we're going to have y2, 5, minus y1, 6. 5 minus 6 is -1. And on the denominator, 6 minus 5, which is +1. So -1 over 1 or just -1. Excellent. Let's see. Not here. Vanessa, number 10. 0. Nice. Which means it's a horizontal line. So on our numerator, we've got -4 minus -4 for y2 minus y1 over 1 minus 9, which is -8, which the -8 honestly doesn't matter. What matters is 0 divided by anything is equal to 0, which means that we've got ourselves a horizontal line for number 10. Do we have any questions on those before we take a look at the last two? All right, go ahead and flip it on over. Or move on to that second page there, and we will look at the last few problems, starting with number 11. So problem number 11. Gwen, what do you have for number 11? -7 over 2. Nice. You got it. So number 11, -7 over 2. We've got -2 minus -9 for the numerator, which is -2 plus 9, which is 7. And then on the denominator, 3 minus 5 is -2. You could have 7 over -2. You could have -7 over 2, or you could have the negative off to the side and then 7 over 2. So as long as there's one negative with that fraction, you're good to go. And the last one, not here. Let's see, already answered. Staley, what do you have for number 12? What'd you get? Not yet? Okay. So what do you have? Do you have the numerator yet? Not yet? Okay. So let's go and work through this together. So the numerator should be 8 minus 6. Because we got y2 is 8, y1 is 6. So 8 minus 6 gives us a numerator of 2. And then the denominator will be 4 minus 4. So Staley, real quick, what's 4 minus 4? 0. All right, so 2 over 0. This one is a lot like number 6. If you have a denominator of 0, and this is something that I've noticed that a few people are going to need to remind themselves of. If your denominator is 0, you're not going to leave it as -3 over 0 or 2 over 0. You're going to write what instead? Undefined. Good. So that is a vertical line with an undefined slope for problem number 12. Excellent. Nicely done. So we've got ourselves an assignment that I'm going to get handed out, and you're going to have about 15 minutes to get started on that today. So a nice little chunk of time to get work done. It is one side of a piece of paper only, and you're actually only working on 1 through 12. Only work on 1 through 12. You can cross off the 3 at the bottom, 13, 14, 15. Don't worry about it. So you cross off 13, 14, and 15. Yeah. So just 1 through 12. Yeah. The first 6 problems are like what we did yesterday. And the second 6 problems are like what we did today. to get started on this. And I mean, 15 minutes, honestly, that might be enough time for some people to get all 12 of these done before we go to really nice amount of people. So get working on that. Let me know if you have any questions.